This is the second part of our discussion on the distance formula. Let's continue on with some of these exercises. Exercise number 4 on the handout is, which point is closer to the origin, 6, 7, or 5, negative 8? Now you don't have to really draw a picture here to solve it, but I wanted to just bring a picture into the video to bring this to life a little bit. And then here's a coordinate grid where I labeled 6, 7, 5, negative 8. Now the origin of the coordinate system is a 0, 0 point. So let's just label that 0, 0. And it's not so obvious to me, staring at this graph paper, whether 6, 7 is closer to 0, 0 or 5, 5, negative 8. I'm just going to try to draw these distances roughly freehand. We're really, comparing each of those two distances, trying to figure out which one is longer, or which one is shorter, actually. The closer point will have the shorter distance. So let's just note that the origin is 0, 0. And I think maybe up here, up above, I'm just going to remind us that our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now here, I first have to check the distance between, I'm not going to use 6, 7, and 5, negative 8, because I want to find these distances between these points and 0. I'm going to have to calculate two separate distances, right? So between 6, 7, and 0, 0. And I'm also going to have to calculate the distance between 5, negative 8 and 0, 0. And it doesn't matter which point you call your x1, y1, which point you call your x2, y2 point. Here, because it's a little bit easier to subtract 0, I'm actually going to think of my 6, 7 as the x2, y2 point. So I can take 6 minus 0 squared plus 7 minus 0 squared. And I get the square root of 6 squared plus 7 squared. Can't say it's 6 plus 7. It's not going to turn out to be 6 plus 7, which is 13. I have to first square 36 plus 49, and I get the square root of 70, 85. And because I'm just trying to figure out which one is closer, I'm not so much concerned about simplified form here for the distance, but even 85, 80, let's see, 85, why don't we just think about it for a second though. 85 is 5 times 17, I think. If I divide 85 by 5, I get 17. And I'm not finding a perfect square factor. Those are both prime. That's actually a simplified form, square root of 85. Now let's calculate my other distance. We could maybe call these D1 and D2 since they're different. Square root of, I'm going to call 5, negative 8 my x2, y2 point again, so I can put those coordinates first in the subtraction. 5 minus 0 squared plus negative 8 minus 0 squared. So I have the square root of 5 squared plus a negative 8 squared. So, sometimes we end up squaring a negative, but the square of the negative will be positive. So I have 25 plus 64 is going to be the square root of 89. And I notice that this one's smaller, so the square root of 85 is smaller than the square root of 89. So our conclusion here is that 6, 7, so this was a smaller distance, 6, 7 is closer to the origin. Now let's do, all right, so there we go with the whole problem there on the screen. Here we have a similar kind of question, number 5. Which point is closer to negative 2, 1, negative 6, 3, or 3, 0? Another little graph grid here to show us. So we're really, here we're measuring like this distance. That's one of them. And then from negative 6, 3 to 2, 1 is the other one. Not so obvious to me again which one's shorter here. We're trying to find out, is this distance shorter or is that distance shorter of the two? And so let's see, we need to take the distance between negative 6, 3 and negative 2, 1. And we also need to take the distance between 3, 0 and negative 2, 1, right? So negative 2, 1 we use in each case. Again, I guess I'll use my negative 2, 1 as my x2, y2 point. So I'm going to have negative 2 minus a negative 6, so double negative minus sign there, squared for the x's, plus 1 minus 3 squared. My first distance calculation, so get the square root of, now negative 2, that's negative 2 plus 6 squared plus a negative 2 squared, 1 minus 3. So that negative 6 plus 2 is a positive 4 squared plus a negative 2 squared. It's going to be 16 plus 4 is 20. And now for comparison's sake, I can leave it like this, but I just going to go a step further here because I know 20 is 4 times 5, and I can take the square root of 4. So we can write that distance as 2 radical 5. Let's go ahead and compute the other distance now between 3, 0, these distance 1 and distance 2 again, between 3, 0, and that's negative 2, 1. That's a negative 2 there. It's an attempt at putting a comma in between. So I'll do negative 2 minus 3 squared, x2 minus x1 squared, plus 1 minus 0 squared. I get the square root of, this is like a negative, what's a negative? A negative 5 squared plus 1 squared is the square root of positive 25 plus 1. 1 squared is just 1. Or positive 26. Now 26 is just 2 times 13. That one I don't think I can simplify further. And if I'm trying to find out which distance is smaller, it's probably easier if I rely on when I had just a single number inside this square root here. If they look totally different, you can always pull out a calculator and compare the decimals if that helps you. But there's the smaller, right? That's square root of 20. So negative 6, 3 is closer to negative 2, 1. And we got our number 5 problem done. And we got a couple more to do. Let's see. On our handout, the next problem is number 6. Show that the triangle with those vertices is isosceles. And I went ahead and just, I got a little bit of a sketch here. Here's the point 0, 2. I've already labeled the point. Here's negative 3, negative 1. Here's the point negative 4, 3. So by triangle with those vertices, I mean if we connect them up, like so, okay, we get a 3-sided figure. The question is that an isosceles triangle? What does isosceles mean? Isosceles means that 2 sides are equal, have the same length. So what we're going to do is we're going to start calculating these distances. We may have to do all 3 distances to actually see if 2 of them are the same. So I'm going to calculate each one of those 3 distances. Actually, as soon as we find out 2 are the same, we'll be done. So maybe I'll start out with the point 0, 2, negative 3, negative 1. So I'm going to find the distance between those two. Negative 3 minus 0 squared, difference of the x's squared, plus negative 1 minus 2 squared, difference of the y squares. And so I got the square root of negative 3 squared, plus I have another negative 3 squared, I believe, right? Negative 1 and negative 2. So I have the square root of 9 plus 9, which is the square root of 18. And if I want to simplify here, I can say this is 9 times this 2 inside that square root sign, and I can take the square root of 9 is 3 times the square root of 2, 3 radical 2. So I got one of my distances here. Let's see. Now let's do maybe 0, 2, and negative 4, 3. Call that distance 1. Now we got distance 2, a separate one. Square root of negative 4 minus 0 squared plus 3 minus 2 squared is going to be the square root of negative 4 squared plus 1 squared. It is the square root of 16 plus 1, or square root of 17. Okay, well that's definitely not square root of 18, but it's close. So now we got one more try, we got one more distance to calculate, and if it's equal to one of these two, we have an isosceles triangle. If not, then our triangle is not isosceles. So let's see, we got to use negative 3, negative 1, and negative 4, 3 to get our third side of the triangle, right? Our distance 3, I'll write down here, is the square root of negative 4 minus a negative 3. So I have that double negative there, squared, plus 3 minus a negative 1 squared. That's the square root of, I'll end up with negative 4 plus 3 in parentheses squared, plus 3 minus a negative 1 is 3 plus 1 squared. That's the square root of negative 4 plus 3 is negative 1 squared, plus 4 squared is the square root of 1 plus 16. There's my square root of 17. And now I see I do have 2 of these that came out to be equal. Let's see, 0, 2, 4, negative 3. this is square root of 17 units along that distance. And I think this one turned out to be square root of 17. This was our square root of 18 side down there. So these two are equal. So, so we can conclude D2 equals D3. So yes, the triangle is isosceles. And we got that problem number 6 solved. We did have an isosceles triangle. We got one more exercise to do on the distance formula. This one's a little bit trickier, I guess. Find a point on the y-axis that is equidistant from the points 5, -5, and 1, 1. Equidistant means the same distance from. And let's maybe try to picture this situation a little bit here. I have a graph grid set up. Now, we're not, it's kind of tempting to take the distance between these 2 points, but we're actually trying to find a separate point. We're trying to find some point on the y-axis. So here's my y-axis. Some point here is what we're looking for. Now, we don't know where it is. If we pick a point really close to 1, 1, we know it's not equidistant between these 2 points, because with the distance from 1, 1 to that point and the distance from 5 is going to be way less than the distance from 5, -5 to that point. And actually, if we come down too far this way, the distance from 5, -5 will actually be less than the distance from 1, 1. Even though 1, 1 is close to the y-axis, when we get way down here, 5, -5 is actually closer to a point down here on the y-axis than 1, 1. Somewhere kind of in between. We're trying to find a point where these 2 distances are the same. I don't know what this point is. I'm just going to call it AB. And actually, I know even more than that. Let's not call it AB. If it's on the y-axis, I know its x-coordinate is 0. So let's just call it 0b, kind of like a y-intercept. So let's call it 0b. We want these 2 distances equal. So we want the distance from 1, 1 to 0b equal to the distance from 5, -5 to 0b. And then we're going to see if we can figure out what b has to be. Now let me do some calculations here. So we want the distance from 1, 1 to 0b. And we're also going to have to calculate the distance from 5, -5 to 0b. And, okay, the distance from 1, 1 to 0b is going to be the square root of, I'm going to use this as my x2, y2 point. So 0 minus 1 squared plus b minus 1 squared is the square root of -1 squared plus b minus 1 squared, which is the square root of 1 plus b minus 1 squared, which is a big mess, okay? Because now I'm going to multiply this out in a bit, the b minus 1 squared, but not just at this moment. Let's go ahead and calculate our other distance. We'll call this distance 1. And then we have our distance 2 is going to be the square root of 0 minus 5 squared plus b minus a negative 5 squared, there, which is the square root of negative 5 squared plus, this is actually going to be b minus a negative 5b plus 5 squared is my d2. So that's the square root of 25 plus b plus 5 squared is my d2. And now what we want, though, is to solve for b out of all of this. And I'm just going to write on a separate sheet because I drew my line too long. So we want d1 to equal d2. So I'm going to take this expression, the square root of 1 plus b minus 1 squared. We want that equal to d2, which is the square root of 25 plus b plus 5 squared. Quite a messy equation. The nice thing is we can square both sides. When we do that, the square root signs go away and we're left with just 1 plus b minus 1 squared equals 25 plus b plus 5 squared. We want to try to solve for b. Okay. Now, I could have multiplied out these squares earlier. It would have been perfectly okay, and I'm going to have to do it now. And but let's just remember now, b minus 1 squared means b minus 1 times b minus 1. b plus 5 squared means b plus 5 times b plus 5. These are like little FOIL problems. I have 1 plus b squared minus b plus 1 equals 25 on the right-hand side, plus I get b squared plus 5b plus 5b plus 25. And what I'm going to do now is combine like terms. Notice I'll put the b squared first. I have a b squared minus 2b, these guys, plus, now I have plus 2. I have a total of plus 2, the one from in front and the one from the tail end there, equals b squared on the right, plus I have 10b, and it looks like I have plus 50. Okay. Now, I'm trying to solve for b. So what can I do here? Well, actually there is something I can do that's very nice. I can subtract b squared from both sides of this equation, and it gets much less complicated then. I have minus 2b plus 2 equals 10b plus 50. So suddenly this big mess has turned into a much less complicated equation. I can subtract 10b from both sides. I'll have minus 12b plus 2 is 50. I can subtract 2 from both sides. Minus 12b is going to be 48. And then I can divide by negative 12. And I think I get b is equal to a negative 4. Okay. So, I guess I'm writing on my graph from before on the back side of that sheet. So what we found out is this point, I didn't quite hit it right here. Actually, the point we want is right here. It's at 0, negative 4. This distance and this distance are actually exactly equal to each other. Because, so let's answer our question here. So it was, it's the point 0, -4, because we knew the x-coordinate was 0. The point 0, -4 is equidistant from, what were those other 2 points? 5, -5, and it was 1, 1. So the key was finding that b-value of 1, but the actual point here that's equidistant is 0, -4. I'm going to try to get as much of this on the screen as I can, and I may even zoom out a bit here to get more of this problem. Okay, I still only have the, okay, I don't have the initial part of the problem showing up. Zoom out a little bit more. Bring that up. There we go. And let me see if I can get a focus. And that was our last distance formula problem. And we'll move on to midpoint formula in our next video.